Alright, so this worksheet's going to take you through Newton's second law. It's going to introduce and help solidify the idea that the net force on an object is equal to the object's mass multiplied by its acceleration. We've seen several examples of this in class, but now let's take a look at this worksheet. We'll do 1 and 2 together to kind of get you started. 1A, if you read the problem, it says this crate here is 100 kilograms, and B and Alice are trying to move it. Well, the first question is, what is the net force on the crate? Well, you can see this is an overhead view, as all these problems are, of a bird kind of looking down at the situation, and we see B pushing to the left with 85 newtons, Alice pushing to the right with a force of 100 newtons, and it says, what is the net force on the crate? Alright, that's easy, right? We're just going to subtract those two, and we get a net force of 15 newtons. But then it says, what is the acceleration of the crate? Well, now we can come over here and apply Newton's second law, right? That says F equals ma. Force equals mass times acceleration. If I know the net force is 15, right? So 15 newtons equals the mass of the crate, which was 100 kilograms. I can solve for acceleration. So I divide that, 15 divided by 100, and I get 0.15 meters per second squared. Okay? Now taking a look at number 2. Alice and B start to cooperate a bit. The forces they exert are shown. Okay? But now their forces are at right angles to each other. You can see B pushes up or north with 85 newtons, and Alice pushes right with 100 newtons. So the first thing it says, what is the net force on the crate? Well, to do this problem, we can do 2 things. First, we can find the net force in both directions. So what I would say is the sum or the net, that's the symbol, by the way, is sigma, and it also means net, right? It means the summation of all the forces. So we'll call this the x direction. The net force in the x direction is 100 newtons. Let's cross that out. And the net force in the y direction is 85 newtons. I probably don't need to explain to you why that is, but again, B is pushing in the y direction at 85, and then Alice is pushing in the x direction at 100. Well, so since these forces are at right angles to each other, we can rearrange them, and we need to find the hypotenuse. So I'm going to bring the 100 Newton force here so that these two vectors are added tip to tail, and what we're going to find is this hypotenuse of this triangle, and that will be our net force on the crate. So if you do the Pythagorean theorem here, this side is 85, this side is 100, you get a net force of 131.2 newtons. Okay, so that's the net force on the crate. What is the acceleration of the crate? Well, now we're going to take this number and we're going to apply it into Newton's second law. So I'm going to say 131.2, got to keep the 0.2 in there, equals the mass of the crate, which is 100 times acceleration. And now I can solve for my acceleration, which is going to be 131.2 newtons divided by 100 kilograms, and that gives me an acceleration of 1.312 meters per second squared. And then, as will be for the remainder of semester 1, season 2 equations, the Vividat equations, they can pop up at any time. So now, any question that asks, how far does it move, right? Remember, that's asking, but as for how far, they're really looking for delta x. This is how far does it move in 2 seconds. It's initially at rest. So we know VI is 0. So we can use this equation. Since VI is 0, then this becomes nothing. We can plug our acceleration in right there. we've got the time at 2 seconds, and we can find the distance the object moves. So that's how you do the work on this worksheet. Now the problems are going to be a little different, but the concepts will be the same.